now we're going to look at the law of signs, but now we're specifically looking at what's called the ambiguous case. Now, if you go back and refer to the congruence and similarity axioms and from geometry, you know, the ASA and the SSS, side, 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 such as that, you never dealt with the one that was side, side angle. I will put it that way, okay? Ha ha, he, you can turn it around and figure it out for yourself. We never did the dirty word. It was just, it didn't work. You cannot use angle side side to prove that two triangles are congruent. And there's a reason for that. Let's kind of delve into this problem right here, and we'll prove it. We'll open that little can of worms. So this is going to vary from what we did earlier because I'm only giving you one angle. All right? If I tell you that angle A is 30 degrees and side A is 8 and little b is 14, this is what happens. So basically, I'm asking you solve the triangle. Okay? So we've got 8 over sine 30 equals, let's see here, that's going to be 14 over sine of b. So this is a little different. I'm solving for an angle. Earlier, we haven't done that. We've been solving for sides, so it's got a different feel to it already. Solving for an angle means that I'm going to have to use my inverse sine. All right, if we go through and we cross multiply, I have 14 sine 30. Now, hopefully, in your brain, somewhere back there, you know sine 30 is 1/2. But if you don't, you can grab your calculator, and you can type that in there, and you can get 14 sine 30, and you're going to get this lovely little decimal right here when you divide it all out, 0.875. Okay, so remember, to get rid of sine, that's inverse sine, and then we're going to need to pull up that decimal. By the way, we do need to be in degrees here. These law of sines and law of cosines works in degrees, not radians. Okay, so this is going to be 61 degrees. Now there's some change there, but if we round it to match significant digits, as we're staying at 61. Okay, well that doesn't seem too bad at all. Not bad in the least. But let's just think for a second. Let's see if we can take in the picture. What we did is we came in here and we set angle A to be 30 degrees. All right, so this is set in stone at 30 degrees. We set this side to be 14, let's just say inches. All right. And then we set side B to be, okay, this is side B. We set side A, which is this side right here. We set it to be, what did we say, 8? Okay, well that looks like that would work. But we don't know what this angle is. We don't know what this angle is. This is a question mark. This is a question mark, as well as this bottom side down here. None of that is locked in. So what is to prohibit this length of 8 from swinging in here? It can still have a length of 8. This 14 can still be locked in. This 30 degrees can still be locked in. Everything that's supposed to be locked can still be locked. But you now have a totally different triangle. This is why this is not, it does not work. SSA does not work for similarity and congruence. That's why you didn't learn it in geometry for those 2 chapters that you went over that. Because you have this ambiguity of which triangle is it. Well, for us in trig, we are looking to solve the triangle. What it's going to do for us is it creates options. So this is the reason why it's called the ambiguous case. It could be this case, or it could be this case. You have to cover both of them, just to be sure. So, now, the relationship between this angle and this angle, hopefully you figured it out, they are complementary. So if you did 180 minus your answer, that's 61, you're going to get 118.9. Well, excuse me, that's not, wait, if I round that up, let's just go to 119. There we go. So we're going to call the first one we got regular old B. And then the second one, we're going to call him B prime. So everything that falls into the category of that original one, the one that was marked in blue, we're going to call him just regular old B, C's, all that kind of stuff. If it's over here with this one that we did kind of in yellow here, those are the ones we're going to call the primes. So that'd be B prime, C prime, all that kind of stuff. But we've still got to find all of the stuff for the triangle. Okay, so let's bump down just a little bit and get some space. Okay, so keep in mind, we know A, we know A is 30, we know little a is 8, we know little b is 14. What we need here is we need C and we need little c, angle C and little c. Now over here, we've got to find C prime, and we've got to find little c prime. So, you've got to go back through using this value right here. You got to figure it out. So, to find the third angle, we got 180 minus 30 minus 61 is 89. So, 89 degrees goes there. And here we go again. We're going to dive in. We got 8 over sine 30 equals, let's see here, C over sine 89. So we're taking this, and we're taking the original, we're making our proportion. Cross multiply. And then divide out that sine of 30. And I am running out of board once again. Let's bump this up some more. Okay, here goes. I think I bumped it up too much. 8 and then sine 89 divided by sine of 30. And that's going to give me, when I round it, it's going to be 16. And that, since that's a side, the other sides look like they were rounded to the nearest integer. So that will do just fine. I've got that one. So, coming back, got to do the same thing for this one. Well, in this scenario, angle A was locked in at 30 degrees. Okay, so I've got 180 minus 30. But this time I'm going to subtract out 119 as angle B. That leaves 31 degrees for my optional angle C. So I get to set it up with same old ratio for A, but this time it's going to be little c prime and sine of 31. Okay, so 8 sine 31 equals c prime sine 30, and then divide through by sine 30. So I've got 8 times sine 31 divided by sine 30, and these are, it's going to be really, really super close to 8 because sine 31 and sine 30 is going to be exceedingly close. So just to differentiate the two, because it ends up being 8.24, you know, I don't want to keep all those decimals just because of the significant digits and such, but I would like to differentiate the two, so I'm going to keep it as 8.2. Okay. That's a personal thing. If you don't like it, do whatever you'd like there. But this gives me, the triangle is solved. I've got all my little parts. I have all the pieces for my blue triangle where I have all acute angles. But then I have all my components, my angles and my sides for my optional triangle, the obtuse triangle, when B prime could have been 119. This is the ambiguous case of the law of sines. So, question is, how do you know when to do this? So, let's kind of look at this. So, things that you can conclude. So, if you're giving, well, let's just make a short list. You need to pay attention. Well, let's see here. When you have SSA, or basically heads up, you are given one angle. That should perk up your eyes, your ears, your brain. That's the first thing that should catch you right there. You have one angle given and you are given two sides. All right, the next thing that you should note is it an acute angle? Because if it's obtuse, how many obtuse angles can you have in a triangle? Only one. So there is no variation. If it's an obtuse triangle, then it's just like the easy version. You just solve it out and you're done. The only variance is if it's acute. So if you're given an acute angle. So if it's acute, heads up, you solve, you find another acute angle. So if you're given acute and you solve it and you find another acute, that's when you know you have the dreaded ambiguous case. That's when you go in and it's not always going to be angle B. It could be angle A or C, but you get the idea. You're going to have to give me what this angle is, or you're going to have to give me the prime version, what it is. So be prepared for that. Heads up. Now, let's just play for just a second. Let's do one real quick. If I have time. I've got a little under 2 minutes. So if we were going to stack this up, we got 12 over sine of 60. And then I have 14 over sine of A. Now notice, one angle, it's acute. I should be watching. So let's see here, 12 sine A, 14 sine 60, divide by 12. Now notice I'm just dividing by 12. The sine goes with the A, okay? Now let's divide all this out. 14 sine 60, hit enter, divide by 12. All right, notice I get a value that's over 1. It's barely over 1, but it's over 1. So when you go and you try to work this out, this is no solution. So you may perk up your eyes and perk up your mind, and it just kind of melt right there before your face. Another thing that could happen is you might be given, and I'm not going to have a whole problem here, but say I gave you an angle and I gave you like 75 degrees. And you solved the problem and you found out that A was 60. Okay? Excuse me, not 60. Let's say A was 25. Okay? That means that I started acute, I ended acute. I have to think through ambiguous, right? Well, let's see here. 180 minus 25 is 155, right? But think for a second. We got just enough time to do this. 155 and 75, 75 and 155, they total together. This is 230 degrees, right? Just two angles. You've already exceeded the capacity of a triangle. 3 angles have to be 180, but these 2 angles have already exceeded this. This is not plausible. It's too large. This is something that happens a lot when you consider the ambiguous case. If your prime case is too big, just exit out, but you need to show where you considered it, okay? But you know it whenever you take the prime case and you add it back to your original angle. It has to be less than 180, because remember the 3 angles have to total 180 altogether. All right, go practice some. Let me know if you have any trouble.